Okay, good morning. This is our sixth episode, season 2 of TACTALK. I'm your host, Alden Morris. Yesterday, we spoke about Mount Rainier and some potential eruption zones, some danger zones, how to basically be prepared. If you live in the area in Washington State, in the vicinity of Mount Rainier, how to be on top of those kind of factors when it comes to potential eruption from Mount Rainier. How you can be prepared to be able to counter that. And I mentioned during yesterday's podcast that I had worked with some companies and some contractors, such as Suspicious Observers, the Thunderbolts Project, Michael Steinbecker, and a lot of those groups that I've worked with before in the past deal with electromagnetic connections between celestial bodies and our planet Earth. And so what I wanted to do today for a podcast is go more into depth about that electromagnetic connectivity. For example, the sun and how it has an effect on Earth, not just when it comes to earthquakes or volcanic eruptions, but gist of kind of it all. So what I'm going to do for you is I'm going to play a video that I made back in October 15th of 2014. So it's going to be going on 4 years here soon. That I made this video, and this is one of the videos I did in support of Suspicious Observers, and the video is called The Solar Kill Shot and How It Affects You. What I'm going to do is I'm going to leave a link here at the YouTube channel, as well as I'll leave another link for the Facebook Live broadcast. So, like I said, this video is called The Solar Kill Shot and How It Affects You. Is published October 15th, 2014 by myself, Alden Morris. And it's about 4 minutes and 32 seconds. So I'm going to go ahead and play it for you here in the first segment. So if you're just tuning in, just know that I'm going to be playing a video. And then in the second segment, I'm going to be going over some more, kind of stressing out some of the key factors that I want to point out for you in the second segment. So without much further, we'll continue this.
The solar kill shot is a mass amount of plasma energy released by the sun capable of destroying the entire electrical grid on Earth and rendering mankind virtually back to the Stone Age. Although the probability of a solar kill shot is unlikely, it is nevertheless something to always be watching for and to be ready for. The sun consists of active regions in which positive and negative polarities either decay and disappear or mix and produce coronal looping and solar flares. Once an active region on the sun is identified, it is numbered and monitored in order to predict possible solar flaring or even coronal mass ejections, also known as CMEs. A CME is a massive burst of solar magnetic fields that rise above the solar corona, the sun's outer atmosphere, and release either into space or in the direction of Earth. Once the negative and positive polarities mix, the solar flare then is closely monitored in order to determine arrival time and possible geomagnetic interference from solar wind speed and density if in the direction of Earth. Solar flares are frequent, but from time to time a powerful solar flare is recorded and placed into the X-class category. Classes of solar flares are based on X-ray brightness and the wavelength range of 1 to 8 angstroms. The three primary classes are C-class flares, small, M-class flares, medium-sized, which can cause brief radio blackouts, and X-class flares, which can trigger planet-wide radio blackouts and long-lasting radiation storms. As seen here on the Enlil spiral, both solar flares and CMEs are recorded and monitored in order to prepare for any possible geomagnetic and electrical interference. When these solar winds reach Earth, the plasma particles wrap around Earth's magnetosphere and meet at the magnetotale on the night side of the planet. These plasma particles rush at Earth's atmosphere and react electromagnetically, helping to create hydrogen and even oxygen. During the arrival of a large CME, or an X-class flare, this enhanced particle precipitation of the solar winds can be seen as the aurora lights. A solar kill shot occurred before in 1859 known as the Carrington event. Dependency on the electrical grid was not what it is now, so the incident was hardly noticed. Nowadays, such an incident would cause an upwards of $2 trillion in damage and may take anywhere between 4 and 10 years to completely rebuild. A reported weakened magnetosphere of up to 15% does little to lessen the probability as well. The first and foremost devastator would be the loss of electricity worldwide. The aurora electrojet would be overcharged, which in turn would induce ground currents that would completely destroy all power transformers and grids. Gas would no longer be pumped as it takes electricity for the lines to operate, and store shelves, pharmacies, convenience stores, and all other supply stores would be bought out or looted within 72 hours. Within the first week, sewage, garbage, and other waste would begin to pile up, causing the spread of illness and disease. Then mass evacuations and relocations would begin to occur. Major metropolitan areas would be the first regions of every country to experience mass panic, riots, and looting in the event of a solar kill shot. These cities easily hold between 20 and 25,000 people per square mile, whose immediate reactions would be to relocate to the nearest urban and suburban zones. This means within the first few days, every city in the world would experience mass evacuations of millions of people at the same time, who are all hungry, cold, and scared. For those already living in the urban and suburban zones, preparations such as food, shelter, and protection will have to have already been prepared beforehand. Areas such as national forests and national parks would become quickly populated with people trying to survive off the land. It is important to know that a solar kill shot can occur at any time regardless of solar minimum or maximum, and it is not just a solar flare that has the potential of becoming a solar kill shot. Coronal mass ejections and plasma destabilizations are also monitored because these two have the capability of rendering Earth's entire electrical grid back 100 years. There is no way to predict when a solar kill shot will occur. However, by maintaining preparations and studying a survivalist lifestyle, you can be of much more help to friends, family, and strangers if one does occur.
Alright, we're going to end it there. So we're just coming up, excuse me, on our first commercial break here, so we're going to end the first segment. But when we get back, I want to talk more about the corona holes that I mentioned in the video from 2014. Coronal mass ejections, obviously solar flares from the different classes of solar flaring, solar winds, what they're made up of. And most importantly, our magnetosphere, how the sun affects our magnetosphere and what our magnetosphere has, how it's changed here on our planet Earth in just our last 100 years. And what that means for you when it comes to traveling, even short distances on a map. So for land navigation, if you have to travel anywhere on foot, you're going to have to be aware of both inclination and declination of magnetic north versus true north. So when we get back, stay tuned. We'll be right back after this commercial break. Again, thanks for listening to TACTALK. I'm your host, Alden Morris. Be right back. Bees Combat Systems at beescombatsystems.com. Protecting those who prepare. 801-987-0893. For custom body armor carriers and tactical gear for military, law enforcement, contractors, corporate security, responsible citizens, and border patrol. Bees Combat Systems at beescombatsystems.com. 801-987-0893. Alright, welcome back to our 6th episode of Season 2 of TACTALK. This is our second segment. I'm your host, Alden Morris. So, before we left for the break, I mentioned a series of things I wanted to talk with you guys about. And, going down the list here, I'm going to try to keep this under 6 minutes if possible. But if we go over, that'll be fine. Coronal holes, CME, solar flaring, things like that. That's all activity that happens on the sun's surface when it comes to how we have different satellites set up, like LASCO C1 and LASCO C2. Those satellites for observing the sun. We've got a satellite set up at different points of the sun. So that way, as the sun's rotating, we can see through different angstrom-colored lenses when it comes to observing the sun, because it is made of plasma. It's very bright, so we study different angstroms, which is basically different color graphs of the sun, whether it's like an orange or a blue or a green or like a neon type color, in order to see this the activity on the sun's surface, because again, it's made from plasma. So you're going to have a lot of activity when it comes to positive and negative polarities and their interaction and the electromagnetic connectivity to itself on the sun. So for example, you imagine like the plasma ball floating in space, and what's keeping that plasma ball from just completely destabilizing and just letting loose over the solar system is the fact that it's got its own electromagnetic force holding it in, like a gravity. Like here we have electromagnetic energies that hold us down, which one could be called gravity. Solar flaring, you have looping, which is again the negative and the positive polarities. They kind of interact and dance on the sun's surface. It's the best way to put it is dance. And every now and then, some get overcharged, some are undercharged, and you have these you have destabilization, which a lot of these are coronal mass ejections. And as the sun rotates, you'll see these coronal mass ejections lose stability and release from the sun's surface past its own type atmosphere type deal, and then it'll come in the direction of our planet. And a lot of these are common when for example, when a coronal mass ejection happens, or a solar flare for that matter. The solar winds, the particles that are in those solar winds, because you got to remember the plasma that was just released off the sun just shot out into space, now in the direction of Earth. What does that mean for Earth? Well, in that particles in the solar winds are usually just, particles like oxygen and hydrogen and carbon, things like that. Literally life-activating particles that are dormant in space, and once they hit Earth's atmosphere, they mix into our electromagnetic connectivity. They kind of activate themselves, and that's how we get, our oceans and our photosynthesis for our plants to grow, things like that. It literally is the life source of our planet because we're in that perfect temperate zone when it comes to where a planet should be in distance and relativity to other planets and the sun itself. So that what we look for in other planets for sustaining life. So again, the sun is the life source of all of our energy here on the planet, and those solar winds, when they come here at the direction of Earth, those solar winds have particles such as hydrogen and oxygen. So can't get much more simpler than that. And the reason why we observe this as much as we do, well, it's taxpayer funded, but we've been observing the sun, for example, our gods, for thousands of years. And we have a lot of work with NASA. In fact, we do so much work with NASA, we can tell when they cover up certain footage, like when a certain coronal mass ejection happens or a certain type class flare, and low spirals that are provided by NASA and NOAA on free for certain websites. Will have 6 to 12 hours missing from their graphs. Look at the KP index, and it'll be kind of off the charts when it comes to an X-class flare. So a lot of this is, again, it's first-hand information. You're getting it live right there on the spot. It's taxpayer-funded, so it's all public knowledge. You don't need a FOIA request or anything like that, Freedom of Information Act request. It's weird. Oh, that's kind of weird. Had an alarm going off. Didn't recognize it. Sorry about that. Anyways, moving on. When we have a large X-class flare, the ability for these X-class flares, and this is why I titled the video "The Solar Kill Shot and How It Affects You," is because the ability for these charged particles that release from the sun when they hit our atmosphere, they hit what's called first a magnetosphere, which is kind of our magnetic shield that blocks our planet Earth in the sun and space from different quasars and pulsars and things like that when they come at Earth that have high charged radioactive waves. These particles bend around the back of the magnetosphere, hit the magnetosphere tail, and they kind of come in charged, and that's how we see it coming into our atmosphere as the aurora borealis that happens. Those are charged particles hitting our atmosphere literally right before our eyes, and they turn that neon color and things like that. So that's one of the most interesting things that people don't know is those are charged hydrogen and oxygen carbon particles. But the magnetosphere is so important because as time progresses, the magnetosphere actually shifts and shapes and things like that. And it's actually grown weaker by a significant amount in just the last 20 to 40 years. And it's become so noticeable that our North Pole has actually started traveling from the North Pole through upwards of Siberia. It's traveling at so many miles per year that it's actually thrown compasses off. And if you look at certain articles done by airports, specifically airports, international airports like SeaTac here out of my own home state here in Washington, a lot of airports have actually had to remark their runways because of the significant change in the traveling North Pole. It makes it harder for pilots who are flying in and out of a commercial international airport, who rely on traditional north when it comes to mapping, for calculating the next stop and drop off and arrival, versus magnetic north, what they're actually using while they're flying. The changes have become so significant that they've actually had to remark runways for pilots who are reliant on the magnetic north on the tools while they're flying. So again, for example, if I wanted to hike from Seattle, Washington, let's say I want to go to Canada, There's a specific spot in Canada. Let's say, I don't know. Let's just say anywhere in Canada. How about that? I could pull out a map and a compass, and I could follow that north bend, that area that's straight true north on my compass, and I would not arrive at the spot that I'm gonna be aiming for because of the declination of my area. Now, every area is gonna have a different inclination or a declination when it comes to magnetic north. And magnetic north, it's traveled. So, for example, here in my Seattle area, it's gonna be 14 degrees declination, which is like a positive, negative. I mean, inclination is positive. 14 degrees declination for true north versus magnetic north. So what I would do is I'll write that on a map, and then that's the direction I travel. Instead of going towards true north, I would travel that 14 degrees declination off my compass. So we've got more videos on just that factor alone. This was one of the key things I wanted to hit. We're coming up on 7.5 minutes here, so I wanted to make sure that we didn't go over too bad. Sorry for boring you there for a minute, but if you stayed and listened to this whole thing, congratulations, you can stand me. So we're gonna end the video there. We're gonna try to do another one tomorrow, and I have a couple video topics for tomorrow while we're waiting for some of our guests to get scheduled onto the show. But until then, thanks for listening, guys. This one again was the solar kill shot and how it affects you. And yeah, check out the video. I will leave the link in the Facebook and the YouTube link for this podcast, episode 6. And again, thanks for listening, guys. Have a good night.